Good day. My name is Engineer Sonny Oboji, a member of the Nigerian Society of Engineers, and I'll be taking us through maintenance fundamentals. We'll be looking at conceptual clarifications about maintenance, objectives of maintenance. We'll be looking at costs associated with maintenance, then the strategies we need to be able to accomplish our goals in maintenance, and several other issues as it affects carrying out maintenance in our industries. To begin with, what is maintenance? Maintenance can be defined as the aggregation of organized steps taken to ensure that the plant and machinery performance is either retained or restored to the desired levels. Now, it is a very big concern in most of our industries that our plant operates at installed capacity and that the equipment don't deteriorate with time. We know that as a result of prolonged use and continuous use, the quality of the equipment goes down with time, wear and tear, and so many other issues. So the function of maintenance is to make sure that we either retain them at the level of performance that they were installed or as close to it as possible, or in case there's a breakdown, we try to restore them to such levels of performance. Now, the actions involved in maintenance include simple steps like inspection of your machines, cleaning of machines, servicing, repairs, some little modifications so that they can get adjusted to your operating environment and to your operating needs as the case may be. Then, in some other cases, overhaul, where you have to strip down the entire machine into component parts to be able to inspect and see parts that are faulty, and then you either repair or you replace, or assemble the machine, test again, and deploy to use, or even condition monitoring. So the actions that take place during maintenance operations vary depending on the need and the situation. But the overall aim of maintenance is to increase the availability and the reliability of plant and equipment. It is not enough that you have machines. The machines must be ready to be used as and when you need them, and they must perform satisfactorily. So in availability, we're talking about the fact that the machine is physically present and in a state where you can deploy it to use immediately as soon as the need arises. What are the objectives of maintenance? The objectives of maintenance vary, but taking a look at them holistically, I'd like to say the objective of maintenance include risk reduction. We want to reduce risk associated with use of malfunctioning machine. This risk will involve damage to human lives, damage to property, damage to the materials you are trying to produce or the ones you are using to work, and environmental related issues. So reduction of risk is a major objective of maintenance. We want to optimize the useful life of the machine, make it to be able to serve as much as possible so that we can recoup our initial investment and make some profit from the machine. We want to maximize the return on investment from every investment that was made trying to put that machine in place. We want to provide budgetary control. Every manager is interested in the fact that if you have a budget and there are limits that are set in every budget, you don't want to exceed the limits. The aim of maintenance is to make sure that the maintenance budget shrinks, maintenance expenditure shrinks as much as possible, and the machines are working and in top condition. So we want to maximize, we want to provide budgetary control to make sure that we don't spend beyond our vote. We want to optimize resources so that at every point in time, all our machines are deployed to work and they are working satisfactorily. And I could make choice because the machines are in good condition. Depending on the dynamics of the order and whatever I want to produce, I could choose, okay, let me use machine on line 1, machine on line 2, machine on line 3 for, as is the best case. Then we want to make sure that our operating costs are kept at the least permissible level, because the more the costs go high, the more your profit margin reduces, and that's not good for business. We want to reduce breakdowns and the downtimes that are the consequence of the breakdowns that we have in the industry. We want the machines to be able to work. whenever they are supposed to work, and there should be no interruptions. Imagine a scenario where you have already started production, midway into the production, there's a breakdown, and as such, you cannot continue with what they are producing. Some of the materials already being processed, which we call work in progress, might get damaged. And when they get damaged, that's a serious loss to the company. Now, you might be lucky if it is something that you could reintroduce into the line and try to rework. But if it's such that the conversion has taken it to a stage where you cannot bring it on board again, then it's a total loss to the company. We want to reduce breakdown. Another issue that is connected to breakdown is when you have a breakdown, definitely your workforce will be rendered redundant, and they will not be working for that window of time while the machine is down. But you have to pay them, especially if they are your permanent staff. You have to pay them. If they are contract or other staff, you could tell them, please go back and come again when the machines are okay. But if they are your permanent staff, you have to pay them. Other running costs, like if you are using alternative power supply or the public power supply, will be running, not minding the fact that your machine is down and you are not producing. All these costs are associated. They are consequential costs that are tied to the issue of breakdown. So we want to reduce downtime, we want to reduce breakdown. Another objective of maintenance is to improve safety so that we can work with confidence. The workmen and every other person in the factory environment can work with every level of assurance that they are safe and that they could work in that environment. We want to improve equipment reliability, want to improve equipment efficiency, want to improve inventory control, and want to maximize production. And lastly, want to minimize consumption of energy, which is a global issue. Now, that takes me to the types of maintenance that we have. There are different approaches to maintenance, and the strategy depends on a whole lot of factors. The scale of operation, the nature of operation, what you are into, the level of expertise that is available in terms of your maintenance crew, your workforce, the extent of funds that is available for maintenance, and the kind of technology that you are deploying, and so many other factors. All these come to play when you are choosing the maintenance strategy to use in your factory environment or in your company. Now, if we are to class all the approaches to maintenance into two broad categories, we'll say all maintenance either fall under planned maintenance or unplanned maintenance. Planned maintenance is the approach to maintenance that gives you the luxury of deciding your course of action ahead of the occurrence of a breakdown. You have enough time to plan what to do, when to do it, and to what extent you will do it before the breakdown happens. That is planned maintenance. And there are so many strategies that we're going to look at under planned maintenance. Then the other side is the unplanned maintenance. Unplanned maintenance, as the name suggests, is that you never planned for it. It just took you by surprise, and all of a sudden you just have a fault, and you must attend to that fault to make sure that production continues or operations resume. And we have two broad categories of maintenance under unplanned maintenance. There is the emergency maintenance, and there is the breakdown maintenance. The emergency maintenance, as the name applies, just there's an emergency, and you need to stop every other thing and attend to it so that you can get that error corrected and you resume operations. Breakdown maintenance, the machine is operating, and all of a sudden, maybe because a part goes faulty or something happens, you cannot operate that machine again. You have to give attention to that particular one. It may not be an emergency, but you might need to be able to attend to it immediately. And so if you have the luxury of maybe you have another machine that is good and that could be swapped, you could pull this one out of production so that you can give it attention and move in the other one. But if not, you have to stop operations temporarily and attend to it. So we have emergency maintenance and breakdown maintenance as the two major groups under unplanned maintenance. But we want to concentrate on planned maintenance. And under planned maintenance, we have several other maintenance types or maintenance strategies that fall under planned maintenance. The very first one is statutory maintenance. Statutory maintenance is maintenance activities that must be carried out statutorily or because there's an existing legislation or a law that demands that you must carry out that kind of maintenance. You don't have the liberty to say, I will not do it or not. Because where there's a legislation or where there's a regulation, you can be sure that there are supervising authorities that want to be sure that it has been complied with to the letter. So everything you do, because you want to play by the rules or there's a law that you must comply with, falls under statutory maintenance. The next one is predictive maintenance. Predictive maintenance. Under predictive maintenance, we are looking at the maintenance approach where you try as much as possible to predict, to identify the occurrence of errors and to predict how long it will take, for them to develop into full-blown faults that are capable of shutting down your operations. And if you're able to establish a timeline, then you plan ahead and move to stopping or to providing some kind of intervention before the breakdown finally occurs. There are two approaches to predictive maintenance. There is what we call the condition-based maintenance. And here, what you do under condition-based predictive maintenance is that you monitor the machine or the components of the machine. You look at the faults as they develop. For instance, you have a shaft and there's a crack in that shaft, but it has not broken the shaft into two. The shaft is still functioning, it's still carrying out its desired function. And so you begin to monitor, you track the development of that crack. Maybe yesterday you saw that the crack was just 1 cm in length. By the time you come in 2 weeks' time, you discover that the crack has grown to about 5 cm in length. And the overall thickness of the shaft is, let's say, about 10 centimeters. Then you know that if it took this long to reach halfway, it will take probably that long, all other things being equal, to divide the shaft into two. You now compare it with your next scheduled period for maintenance. And if you discover that you have enough time, that the graduation in this fault development is such that your next scheduled period for maintenance comes before there's the damage in the equipment, what do? You might not really need to give it attention. You can concentrate on other ones while you plan to intervene. But if you discover that you don't have the luxury of time and it's going to fail before your next scheduled time for maintenance, then you move in to be able to effect maintenance. And you can do condition-based predictive maintenance through the use of sophisticated equipment like vibrometers, like temperature scales that help you to be able to take accurate readings that are not dependent on subjective evaluation by the person that is carrying out the maintenance. The other angle to it is the statistical-based predictive approach. And here, what happens is that you keep accurate record of fault occurrences, their frequency of occurrence, the description of the scale of occurrence and everything. And on the basis of that, you are able to predict and establish timelines and be able to predict accurately what will happen when, and you can move in to effect corrections before then. Then we have what we call the preventive maintenance. Preventive maintenance, as the name implies, involves all the steps you take in maintenance to be able to prevent the occurrence of a fault. And if you cannot entirely prevent it, to limit the scale of occurrence for cases where you cannot entirely prevent it. And under preventive maintenance, we have things like the unit-based maintenance, we have the running maintenance. Running maintenance, what it means is that the machine is simply running, and all the maintenance activities, the procedures that you can carry out while the machine is running that do not interrupt the functioning of the machine, they come under running maintenance. For instance, you could decide to check the condition of some loops and do some topping, as the case may be. Some minor tightening and adjustment can happen while the machine is running. For instance, in the industry, if you have a belt, a flat belt, a conveyor belt that runs between two rollers at extreme ends, and you want to track the belt. Tracking is the operation where you ensure that the belt moves in a very parallel way so that the belt does not slide to one side and get entangled with the ends of the roller. It's a very important procedure in industry when you're running conveyors and other flat belt driven drives. Now, you want to be sure that when you track, that you get the belt in a fixed position and it runs steadily as long as you want it to be. Now, there's no way you can track a flat belt while the machine is off. It must be running. That's where you do a little adjustment there and you compensate at the opposite end until the belt is balanced and there's no movement from one side to the other again. So that's an example of running maintenance. Then we have routine maintenance. As the name implies, these are things you carry out on routine basis. There's a timetable that guarantees that different components of the plant, of the equipment, different parts of the machine are given attention based on a calendar. There are some you attend to on weekly basis, some you attend to on monthly basis, some you attend to on quarterly basis, some you do once in a year. It depends on the complexity and the need of the machine. Things like oiling, greasing, and several other simple operations come in under routine maintenance. Then we have the shutdown preventive maintenance, where here you just have to shut down the machine or shut down the equipment so that it will give you the time, the flexibility, and the opportunity to be able to concentrate on whatever you are doing and to do it without any form of distraction. Then also under plant maintenance, we have another approach, which is what? The improvement maintenance. Under improvement maintenance strategy, we have engineering services and design out. And of course, the shutdown improvement. Improvement maintenance is all about what? Trying to improve the maintenance procedures that you carry out to improve the functionality of the machine, to make sure that it functions at an improved level, is able to churn out better product, is able to work, spending less time than it consumed before, you are able to cut down on oil consumption and so many other things, improving the condition of the distance. One of the main strategies under improvement maintenance is what we call the design out maintenance. Design out maintenance. So many machines are imported, so many machines are brought in from external clients into this country, and you discover that there's a slight variation, or sometimes there are serious variations between our operating conditions and the operating conditions in the client where these machines were designed to operate. And so as a result of maybe the harsh environment or the rate of use, the kind of use that is subjected to the workload and everything, because that certain parts of machines begin to fail regularly, they fail regularly. And if you are to allow them to continue running like that, it will interrupt your productions and it's going to lead to a buildup of different costs that you don't want to entertain. So what do? You now think of how to adapt that machine or a part of that machine, some subsystems in that machine, to run in our own environment. This is where you consider knocking out some drives and introducing some other drives. For instance, you remove more flexible drives, or drives that are very fragile. You take them out and you bring stronger drives and drives that are rigid. You may consider things like eliminating a belt drive, for instance, and bringing a chain drive, maybe because you are using it to drive loads at lower speed than what you would have needed a belt drive to do. So when you modify a machine, you redesign a machine, knock out a portion of that machine and introduce another system or subsystem so that it will help your overall functionality of the machine, we say you are engaged in design out maintenance. And of course, also, you could shut down to carry out a design out depending on the scale of operations, or you might just do it within a short interval and this thing. Then we have corrective maintenance as part of planned maintenance. You have a part of your machine that is always giving you issues and whatever, and you decide to do some root cause analysis, investigation. You want to find out what is responsible, what's the root cause, what is causing this, and then you move in to correct, to eliminate everything so that you will not have that breakdown again. That's corrective maintenance. And we have remedial maintenance and deferred maintenance, all under corrective. Either you want to provide some remedy to get, for instance, you have a batch that already you have started producing and it is running. You cannot afford to stop the machine that will result in damaging whatever work you have in progress. So what do you do to provide some remedy so that the batch runs out and then you can have your time to really do the correction that you want to do? That's remedial maintenance. Defer, you've noticed the fault. You know that the fault is not as serious as warranting the shutting down of operation. So you can afford to schedule it again some other time. But of course, you know that you have to go and give it attention. Now, the trap there is that sometimes when we defer some work, we forget and we don't always go back to attend to those works. And they get worse. The condition of those parts or those subsystems get worse and they become major issues. That is one. Sometimes you might not even forget, but other faults come up, and on your priority ranking, they are more important and more urgent, demanding urgent attention than the one you have deferred. And so you see that the job you deferred becomes a sacrificial lamb when compared to the other ones that are coming up. All these are issues that come up under corrective maintenance using the deferred strategy. So we have looked at different approaches to maintenance. Permit me to also mention window maintenance. Under window maintenance, this is the part of plant maintenance, you have certain window of time. For instance, in most factories, you discover that during break, it could be between 12:1, it could be between 1:2, everybody is supposed to stop producing. All workers in the production floor have to go out, maybe to go and observe the break period before they come back. Now, that is a very good opportunity. One, because it is predictable. You know that the break time yesterday is the same thing as the break time today, and it will be the break period tomorrow. For the maintenance crew to rush in while there's no interference or interruption from the production crew, for you to go in, do all what you are supposed to do, and put the machines back in order. We call that window maintenance. And it's very, very important. The advantage is that it will help you decongest your workload, all what you have scheduled to do at the weekend and whatever. You are able to decongest this thing, and you have some time to do some quality work. You'll not be working under pressure at weekends again. Then there's what we call opportunity preventive maintenance. Under opportunity preventive maintenance, what happens is that there is a stoppage, not because of a breakdown in the machine. For instance, the shop floor could be so jam-packed and there's no space in the store to be able to keep those goods. And you need to be able to, you need some space. So from operations or from production might be halted. They might say, okay, don't produce for now. Don't run for a certain number of hours until we're able to clear the backlog on the shop floor. We're able to clear whatever we have piled up in the store. Then you can now roll out new products and whatever. Now, instead of waiting idly, the maintenance crew, knowing that for the next 4 hours, there's not going to be any form of interruption, and the machines will not be needed, can move to site and see aspects of maintenance, deferred maintenance or issues that have been complained about that they need to attend to just before production resumes. We call it opportunity maintenance, seizing the opportunity that has presented itself because of interruption in production from other quarters. So this is just a brief summary of the different approaches we have to maintenance in our industries. The next thing we want to look at under maintenance is preventive maintenance schedule. Now, in every industry, it doesn't matter the size of the industry, small-scale industry, big industries, you discover that between every maintenance period, most maintenance activities take place during weekends. Between one weekend and the other, or between one maintenance window and the other, different faults develop. And you see a pile-up of needs, of maintenance needs that we necessarily have to be attended to. And so if there's no careful planning or scheduling, we might have a situation where some machines receive attention from time to time and others are neglected. Also, it is not possible and cost-effective most of the time to have all your maintenance crew members attend to maintenance work as overtime work or during weekends. You want to be sure that only those that are necessary, only those that are very, very important and well needed are the ones that are brought on board to handle the operations that are needed that we need to attend to during the weekend. That gives rise to the need to having a maintenance schedule. A preventive maintenance schedule provides a general guideline for maintenance inspection frequencies for equipment often found in the plant, and it is for informational purposes only. Information for who? The technical manager. Normally it is prepared by the maintenance supervisor. He takes a look at all the tasks that are scheduled to be accomplished during the maintenance operation, normally at the weekend or even in the course of the week. Now, having identified all the operations, the next thing is to decide, okay, who are supposed to be on ground to be able to attend to this? What is their level of competence? What is their level of experience concerning this job? What is the assurance that if they are deployed to site, that the fault will be corrected and there will be no rollover? Now, having considered all those factors, they will now list out the jobs and list out the name of the crew members that will be drafted for every of the operation that will be needed to be carried out during the maintenance operation. Now, having done that, he also has to estimate the number of hours assigned to each operation so that there won't be unnecessary wastage of time, or especially when work is paid on hourly basis, like we have in most overtime arrangements. When this is compiled together, he forwards it to the plant engineer, or the plant engineer passes it to the technical manager, who approves it. So the technical manager is informed of whatever is going to happen over the weekend. Now, if the operations require the use of spare parts from the store, then the people in supply chain, the technical store, will have to be informed. If it requires that there will be some outsourcing or whatever, then the people in admin will also have to be informed. If drivers will be needed and other support staff, the people in admin will have to be informed so that they will be able to plan ahead of this. The people in accounts will need to be carried along as well. They need this information to be able to make appropriate budgeting for payment of those that are going to be on board and for services that might be required during the maintenance operation. So the schedule serves to inform different persons so that they can carry out their own aspect of the job as it relates to the overall maintenance function. It is advisable to follow recommended manufacturers' recommendations for maintenance and upkeep of all machines. Normally, every machine will come with recommendations from the manufacturer, and that's based on several tests that have been carried out at different loading levels. And so if a machine is supposed to be attended to on weekly basis, it is advisable to make sure that it is attended to on weekly basis. It is supposed to be attended to on monthly basis, on quarterly basis, or whatever, or aspects of the machine require more regular attention. It should be adhered to strictly so that the machine can be kept useful and it will last as long as possible. A good maintenance schedule will help us to be able to achieve that. Then we look at costs associated with maintenance. What are the costs associated with maintenance? Most of the times, the maintenance crew are not fully aware of the cost, the associated cost with maintenance. There are several other costs that may not come directly as the cost of spare parts or the cost of repair or the cost of an outsourced job or not, but they are all related to maintenance. I want to take a look at some of them just for purpose of enlightenment. We have the cost of facilities dedicated to maintenance department for repair and maintenance. For instance, during maintenance, you may have to run the generator to supply power. If there's no power from the public utility, you may have to make sure that water is running and other things. All these are aspects of facility cost that have to do with what? Maintenance. They add up to the overall maintenance cost because they were not run for production. They were run just because we needed to carry out maintenance at that particular time. The next one is the cost of preventive maintenance to improve the availability of the assets. All the things we looked at under preventive maintenance, as you engage in them, the cost that you incur because of those activities, they all add up to the cost of preventive maintenance. You know, cost of lubrication, cost of changing of parts that have not fully broken down, cost of inspection, cost of testing, non-destructive testing, and every other cost. You need to go through all those. The next cost we are looking at is the cost of resources, like the equipment, cost of tools, and other facilities for condition monitoring and diagnostic equipment. As the name implies, we may need specialized equipment to be able to monitor. For instance, you are using infrared thermometers, you are using vibrometers, you are using special monitors to be able to read, to show you internal condition of parts and to be able to detect the faults that have developed and how the progression is. You may need those specialized equipment. It's either you buy them or you are going to hire them. Now, if you are hiring them, they come at a cost. Even if you are buying them, you are tying down capital because some of them you might not need, you use it regularly. And so you take your decision. Is it cheaper to buy or is it cheaper to rent? Whether you are renting or buying, you are going to have to spend money, and those costs are also part of the overall maintenance cost. The cost of spare parts, lubricants, and other consumables. These are things you use and they get spent or they get spoiled, and you need to bring them on board again. Your gear oils, your lubricating oils, other forms of oils that you need, your spare parts, your consumables, like your the packings, like your mechanical packings, your seals and everything. These are things you use and they deteriorate with time and you need to replace them. All those, the cost associated with them also forms part of the overall maintenance cost. What of the cost of supply chain and inventory management functions? Sometimes the parts you need, if you are lucky, you could source them locally or from nearby sources. Some parts are expensive and you may not be able to get them from local sources. You might need to order them ship them in from abroad and keep them in your stores. And every part that you keep in your store is equal to capital tied down. So if you are keeping a part like a bearing on the shelves of your store for the next 1 year, just imagine that if you use the money that was used to buy that bearing, you convert it into buying of raw materials and production, what it would have generated for you in terms of interest or profit and whatever, then you begin to know what it means to tie down resources. So the cost of spare parts, the sourcing, the storing, and then the deployment to use, every other thing that is handled by supply chain or an inventory management department add up to the overall maintenance cost. What of the stationery and the printing of formats, computers, and other things that you use to be able to prepare your schedules, to issue out circulars and memos, and to do your maintenance documentation so that you have adequate information management as far as maintenance function is concerned? The cost add up to overall maintenance cost. Then some jobs, you might not have capacity to carry out some jobs within your factory, and you might need to take them out to go and work them in some other factories or in some other workshop. For instance, you have a turning operation, you have a machining operation, you need to machine a blank, you need to cut a gear, you need to do some things, or maybe retread an electric motor, and you do not have facilities to carry those ones out within your factory. You might need to take them out. Sometimes the decision to outsource may be based on economic considerations. You discover that it is cheaper outsourcing those jobs than maintaining a workforce that can be able to handle it. And you have to pay them salaries and a whole lot of other overheads. So each time you have to outsource, it comes at a cost and it's part of the maintenance cost. Then the last part is training and development. You need to regularly update your maintenance crew on the latest technologies, the latest innovations, modifications, and everything. There's a new software, for instance, in the market. You need to take them through it so that they will learn. If there's a new approach, new products, you need to take them through it so that they'll be able to learn, new methods. And training and retraining is something that is constantly needed in the maintenance department so that the workers will be updated. It comes at a cost. So if you add up all these costs, you'll be able to establish what your maintenance cost is all about. And the aim, like I said earlier, is to cut down costs. So under this topic of maintenance, we have looked at what maintenance is. We have looked at the objectives of maintenance. Then we examined the different approaches to maintenance under maintenance strategies. And finally, we looked at the cost associated with maintenance. Thank you very much. That will be the end of lesson 1.